Okay, let us start our discussion on how to find out the length of the chord of the curvature passing through the field. Suppose we have a curve here, and the curve have a point x comma y, or we can say that r comma theta here. Keep in mind because we want to find out here the length of the chord of the curvature. Whenever there is a curve, we have a oscillating circle, and we already know how to find out the center of the curvature and small minute change in the whatever the curvature we can get it. That curvature is occupied by one completely becomes part of a circle, that is called osculating circle. And that chord, the center of curvature, means center of the osculating circle is nothing but the center of that curvature. And now we have to find out the length of the chord which passes through the origin. Means you take how to take, I can say, the curve in the polar form. Okay, because in order to make it very easy, if I take the curve in the polar form, what happens, we can say point, if you take it, the point can be joined here, and corresponding that there is a oscillating circle is there. Let the center of that oscillating circle must be passes through the line which is perpendicular to the tangent drawn at the point, because always the radius must be perpendicular to tangent drawn at the point, okay, at p. Therefore I can say that this is the thing. Now initially, as I told you, there is a curve apb, some apb is here, and let phi be the angle between radius vector and I can say that uh, angle between the radius vector and tangent drawn at that point. Okay, now we can say that what we can say, oscillating, draw the oscillating circle origin, and let's see with the center of the uh, I can say that circle, and what we can say that the length is about 2 in 2 row. Okay, then where PR is the diameter, all those things. Now in order to find out very simple logic, what we want, because this card is no that passes through this one origin here, just what you can do here, you can just a curve, and if you take a point here, you take a point on this, and that particular point we can just definitely this we want to find out the length of the PQ. Now the angle between this OP and TP is 5 here, and this is, I can say that 90 minus 5, because entire this is 90 degree, tangent between this radius vector and tangent is 90 degree, this is 90 minus 5. Once it is 90 minus 5, and RQP is 90, and definitely QRP is also 5. Now in this we want actually the length of the PQ, isn't it? That is equal to sine 5 is equal to opposite divided by hypotenuse. Very simple. That is equal to QP is equal to 2 rho into sine 5. That's all. There's nothing is there. 2 rho into sine 5. That's why we are taking, if you in the otherwise if you take cos of QPR, that is nothing but it is again sine 5 on the, that is QP adjacent divided by hypotenuse, that is equal to again, this is how PQ is equal to 2 rho sine phi. This is how you can successfully prove that the length of the curve. Only thing is, whenever there is a curve is there, just we have to draw oscillating circle, and for that we have a center of curvature, and that from the point when you can join the origin, that length we want. Actually they asked to find out the length of the chord passing through the pole. Therefore you can find out like this, and the angle between, we already know this, whenever the polar form is there, you can say that this is the theta, and this is I can say that psi, and this is phi, and this is also pi. Based on this, we can find out the length of the PQ in a very easy manner. Okay.